NEC 225.30 addresses requirements for service disconnecting means. The core principle of NEC 225.30 is that each service disconnecting means must be located at a readily accessible outdoor location, positioned near where the service conductors enter the building. This requirement ensures that in an emergency, or during maintenance, the electrical supply to a building can be quickly and safely disconnected. The code doesn't specifically prohibit installing separate panels for different sections of a building. As long as each disconnecting means adheres to the location requirements of the code, you're generally within compliance. Considering the scenario of adding heating, ventilation, and air conditioning or HVAC to an existing classroom wing, where the existing panel lacks sufficient power, installing a dedicated panel for the HVAC unit on the exterior wall of the building would likely not violate NEC 225.30. This is contingent on the panel having its own disconnecting means situated at a readily accessible outdoor location. This setup aligns with the code's intent of providing a readily accessible disconnect. Now, let's consider the alternative of upgrading the existing feeder and panel to accommodate the new HVAC load. This approach ensures all power is supplied through a single point, potentially simplifying overall electrical distribution. However, it might be more involved and expensive than installing a dedicated panel. Upgrading the existing panel to handle the new heating, ventilation, and air conditioning or HVAC load involves several considerations. Firstly, assessing the current capacity of the existing feeder is crucial. You need to determine if the existing feeder can handle the additional amperage draw of the heating, ventilation, and air conditioning or HVAC system without exceeding its rated capacity. Secondly, the existing panel's breaker slots need evaluation. Check if there is sufficient space within the panel to accommodate the new breaker required for the heating, ventilation, and air conditioning or HVAC unit. If there aren't enough slots, you might need to consider replacing the entire panel with one that has a higher capacity. Thirdly, a load calculation needs performance. Perform a comprehensive load calculation to determine the total electrical load on the existing panel, including the new heating, ventilation, and air conditioning or HVAC load. This calculation will help you verify that the panel and feeder are adequately sized to handle the combined load safely and efficiently. Fourthly, consider the existing grounding system. Ensure the grounding system is adequate to handle the increased load and meet the requirements of the National Electrical Code or NEC. You might need to upgrade the grounding system to ensure proper electrical safety. Fifthly, coordination with the utility company is important. Coordinate with the local utility company to ensure that the existing service can handle the increased load. The utility company might require upgrades to their infrastructure to support the increased demand. Sixthly, the installation process needs adherence to codes and standards. All electrical work must comply with the latest edition of the National Electrical Code or NEC and any applicable local codes and standards. This includes proper wiring methods, overcurrent protection, and grounding techniques. Seventhly, documentation is necessary. Maintain detailed documentation of all upgrades, including load calculations, panel schedules, and inspection reports. This documentation will be valuable for future maintenance and troubleshooting. Eighthly, professional inspection is required. Have the completed work inspected by a qualified electrical inspector to ensure compliance with all applicable codes and standards. The inspector will verify that the installation is safe and meets all requirements. In comparison, installing a dedicated panel for the heating, ventilation, and air conditioning or HVAC system involves these considerations. Firstly, panel sizing is critical. Properly size the dedicated panel to accommodate the heating, ventilation, and air conditioning or HVAC load in any future expansion. The panel should have sufficient breaker slots to handle the heating, ventilation, and air conditioning or HVAC unit and any other equipment that will be connected to it. Secondly, the location of the panel is important. Choose a suitable location for the dedicated panel that is readily accessible and meets the requirements of the National Electrical Code or NEC. The panel should be mounted on a stable surface and protected from the elements. Thirdly, a new feeder installation is necessary. Install a new feeder from the main service to the dedicated panel. The feeder should be sized according to the heating, ventilation, and air conditioning or HVAC load and the requirements of the National Electrical Code or NEC. Fourthly, overcurrent protection is needed. Provide overcurrent protection for the feeder and the heating, ventilation, and air conditioning or HVAC unit. Use appropriately sized circuit breakers or fuses to protect against overloads and short circuits. Fifthly, grounding is important. Ground the dedicated panel and the heating, ventilation, and air conditioning or HVAC unit according to the requirements of the National Electrical Code or NEC. Proper grounding is essential for electrical safety and to prevent electrical shock hazards. Sixthly, coordination with the utility company is important. Coordinate with the local utility company to ensure that the new panel and feeder are compatible with their system. The utility company might have specific requirements for connecting to their grid. Seventhly, adherence to codes and standards is mandatory. All electrical work must comply with the latest edition of the National Electrical Code or NEC and any applicable local codes and standards. This includes proper wiring methods, overcurrent protection, and grounding techniques. Eighthly, documentation is a must. Maintain detailed documentation of all work, including panel schedules, wiring diagrams, and inspection reports. This documentation will be valuable for future maintenance and troubleshooting. Ninthly, professional inspection is required. Have the completed work inspected by a qualified electrical inspector to ensure compliance with all applicable codes and standards. The inspector will verify that the installation is safe and meets all requirements. Deciding between upgrading the existing panel and installing a dedicated panel involves weighing several factors. Cost is a significant consideration. Upgrading the existing panel can be more expensive due to the potential need to replace the entire panel and feeder. A dedicated panel might be more cost-effective if the existing panel has limited capacity. Available space is another factor. If the existing panel has limited space, installing a dedicated panel might be the only viable option. Upgrading the existing panel might require significant modifications to the electrical room or closet. Future expansion plans also play a role. If there are plans for future expansion, a dedicated panel might be a better choice as it can provide additional capacity for new equipment. Upgrading the existing panel might limit future expansion options. System reliability also matters. Installing a dedicated panel can improve system reliability by isolating the heating, ventilation, and air conditioning or HVAC load from other critical systems. Upgrading the existing panel might increase the risk of overloading the system and causing outages. Compliance with codes and standards is paramount. Ensure that all electrical work complies with the latest edition of the National Electrical Code or NEC and any applicable local codes and standards. This includes proper wiring methods, overcurrent protection, and grounding techniques. Ease of maintenance is also important. Installing a dedicated panel can simplify maintenance by providing a separate disconnect for the heating, ventilation, and air conditioning or HVAC system. Upgrading the existing panel might make maintenance more complex as all systems are connected to a single panel. Ultimately, the best option depends on the specific circumstances and requirements of the project. It's recommended to consult with a qualified electrical engineer or contractor to evaluate the options and determine the most appropriate solution. They can assess the existing electrical system, perform load calculations, and provide recommendations based on your specific needs and budget. Remember that proper sizing and protection of the new panel are crucial, regardless of the approach you choose. The panel must be adequately sized to handle the heating, ventilation, and air conditioning or HVAC load, and appropriate overcurrent protection devices, such as circuit breakers or fuses, must be installed to protect against overloads and short circuits. A critical aspect to keep in mind is ensuring the disconnecting means for the heating, ventilation, and air conditioning or HVAC panel is readily accessible and located outdoors. This is in accordance with NEC requirements for service disconnecting means, ensuring quick and safe disconnection of power in emergencies or during maintenance. Always consult with a qualified electrical inspector to ensure all work complies with local codes and regulations. They can provide guidance on specific requirements and ensure that the installation is safe and meets all applicable standards. Consider the impact on the building's overall electrical system. Evaluate how the new heating, ventilation, and air conditioning or HVAC load will affect the existing electrical distribution system. Ensure that the system can handle the increased load without causing voltage drops or other problems. Document all changes to the electrical system, including panel schedules, wiring diagrams, and load calculations. This documentation will be valuable for future maintenance and troubleshooting. Ensure that the electrical system is properly labeled and identified. Label all panels, circuits, and equipment to facilitate maintenance and troubleshooting. Consider the potential for future expansion. Plan for future expansion by providing extra capacity in the new panel and feeder. This will make it easier to add new equipment in the future without having to upgrade the electrical system again. Also, consider energy efficiency. Choose energy-efficient heating, ventilation, and air conditioning or HVAC equipment to reduce energy consumption and lower operating costs. Implement energy-saving measures, such as programmable thermostats and occupancy sensors, to further reduce energy consumption. Don't forget about safety. Prioritize safety in all electrical work. Use proper personal protective equipment, such as gloves and safety glasses, and follow safe work practices. Energize circuits before working on them and use lockout-tagout procedures to prevent accidental energization. Remember that electrical work can be dangerous, so it's important to be careful and follow all safety precautions. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. Moreover, before commencing any electrical work, it's essential to obtain the necessary permits from the local authorities. This ensures that the work complies with all applicable codes and regulations and that it's inspected by a qualified inspector. Obtaining permits can also help to avoid potential fines or penalties. When selecting electrical equipment, such as panels, breakers, and wiring, it's important to choose high-quality products from reputable manufacturers. This will ensure that the equipment is reliable and will perform as expected. Avoid using cheap or substandard equipment, as it can be a safety hazard. High-quality equipment may cost more upfront, but it will save you money in the long run by reducing maintenance costs and preventing breakdowns. When installing wiring, it's important to use the correct size and type of wire for the application. The size of the wire should be based on the amperage rating of the circuit and the length of the wire run. The type of wire should be based on the environment in which it will be installed. For example, if the wire will be exposed to moisture, it should be rated for wet locations. Using the wrong size or type of wire can be a safety hazard and can lead to overheating and fires. Furthermore, when making electrical connections, it's important to use proper techniques and tools. Use wire connectors that are designed for the type of wire being used to make sure that the connections are tight and secure. Avoid using tape or other makeshift methods of making connections, as they can be unreliable and can lead to loose connections and arcing. Loose connections are a common cause of electrical fires. When working with electrical panels, it's important to be aware of the potential hazards. Electrical panels contain live circuits and can be dangerous if not handled properly. Always de-energize the panel before working on it and use a voltage tester to verify that the power is off. Be careful not to touch any of the exposed wires or components inside the panel. Wear appropriate personal protective equipment such as gloves and safety glasses to protect yourself from electrical shock and arc flash. When installing a new electrical panel, it's important to choose a location that is accessible and well ventilated. The panel should be mounted on a stable surface and should be protected from the elements. Avoid installing the panel in a damp or humid location, as this can lead to corrosion and electrical problems. The panel should also be located in an area where it is easily accessible for maintenance and repairs. When labeling electrical panels, circuits, and equipment, it's important to use clear and concise labels that are easy to read. The label should identify the purpose of each circuit and the equipment that it serves. Use a permanent marker or label maker to create the labels and make sure that they are securely attached to the panel or equipment. Proper labeling can help to prevent confusion and errors during maintenance and troubleshooting. Finally, when troubleshooting electrical problems, it's important to use a systematic approach. Start by identifying the symptoms of the problem and then use a process of elimination to narrow down the possible causes. Use a voltage tester and other diagnostic tools to check for voltage continuity and other electrical parameters. Be careful when working with live circuits and always follow safe work practices. If you're not comfortable troubleshooting electrical problems, it's best to hire a qualified electrician to do the work for you. Remember that electrical safety is paramount. Always prioritize safety in all electrical work and follow all applicable codes and standards. Electrical work can be dangerous, so it's important to be careful and take the necessary precautions to protect yourself and others.